This is a video demonstration of the algorithm for optimal camera placement for the camera systems that can detect crime for our final project. Here I'll run the first three code cells. This will import the data from a database from 2003 to 2015 of crimes in San Francisco, and I sorted out the crimes that involve gun, knife, or other deadly weapons. This field is for creating an Esri map where we will be mapping the crimes. So if I run this cell, it would map out the crimes. As you can see, the more red the area is, the more crimes have been committed there. We can also zoom in this map and see more closely which areas have been affected the most. So based on also on statistics, the area near Westfield, the 800 block, is very often affected. And also we can see somewhere here in the intersection between the 7th Street. So this is crime mapping, and we also found the database for lamppost locations on Market Street, and here I'm mapping those. As you can see, those yellow dots are the lampposts located on Market Street. The next section will be definition of the camera system specifications. Here you can change the view radius, so depending whether the city planner wants to use a camera A or camera B, it might have different specifications, and the algorithm is tailored to allow that flexibility. Next thing is this part is calculating the distance between the camera and the place of incidence using a formula involving angles, because the coordinates of the place are written in radians, so we have to convert them to meters. So this part would be defining the formula. This part is telling us how to optimally locate n cameras, where n is the number that we input. So for this part, we'll run through, let's say, from 1 camera to 60 cameras setup, and see how it's okay. So I haven't defined view radius, which is here. I should run this cell first, then we'll run this cell, and it will calculate the efficiency for different configurations of cameras from 1 camera to 60 cameras, and it will plot out the graph. So again, we use the recursion algorithm, which means that we store what is the best configuration for 1 camera, and then we, based off that, we place the second camera in the best position possible, and then the third camera, and until n cameras. So we'll wait a little bit until the algorithm finishes calculating everything. After that, we'll see the same graph as in the paper, and the next part is actually jotting them out on the map. So here I want to place 30 cameras, and I want it to be done automatically. So again, based on the algorithm, it can calculate the efficiency of those, meaning that it will cover 54% of the crimes involving weapons. And you can also see that in the map, it also mapped out the lampposts where the cameras should be installed. These are the blue lampposts here. And also you can notice that if you click on the spots here, like the red one, it will show what kind of incident it is. If you click on the yellow, it will say that it's a lamppost. You click on the blue, it will say that it's a 360-degree camera setup. That's pretty much it. Thank you so much for watching.